Today we will see the simulation of the ray diagrams. So in your previous classes you have learnt about the mirrors and also you have been given an introduction to lenses. So today we will see the ray diagrams of mirror. Okay, so before going into the class, please do subscribe for the channel. So this is the concave mirror. So this is a concave mirror and you can see the point F here. Okay, so this point F is nothing but called as a focus or focal point, and the distance between the focus and pole, that is center of the mirror, is nothing but called as focal length. And here this you can see as 2F. So this 2F is nothing but called as a center, that is center of curvature, and the distance between the center and to the pole is nothing but called as radius of curvature. Clear everyone? See, now here this is the images, that means objects. I can take a candle, or I can take a arrow mark, or I can take a ABC. Okay, so this is a mirror. Okay, and here how much I am taking the focus? I am taking the focus as 20 centimeters. Okay, that means the focus of this concave mirror is 20 centimeters. So in the classes you have learned that ray 1, that is, if in order to draw ray diagrams we need to have rays. Okay, so the first ray which you have read is nothing but the ray which travels parallel to the principal axis and passes through the focus. So now see, clear everyone? So see, this is the ray which is passing parallel to the principal axis and passing through the focus. So this is the R1 ray. Okay, so in order to get the image, how many rays we need? At least minimum 2 rays should meet. Okay, so now I will take in another ray. So what is the R2? R2 is nothing but the ray which travels through the focus, and after reflection it travels parallel to the principal axis. Now we will say R2, that is ray 2. See, so R2, it is passing through the focus and traveling parallel to the principal axis. Is it clear? So these are the 2 rays. Okay, so the reflected rays of these 2 rays are meeting at this point. So you can see the image of the candle. Yes. Is it clear? So this is how the image is formed. So we have another rays also. So here we will see R3. So R3 is the ray if an angle, that is if a ray is meeting the surface with a certain angle. So after reflection what happens? It travels with the same angle, that is angle of refraction will be same, that is angle I will be equal to angle R. Is it clear? So if we consider this ray, this also meets this point. Is it clear? So now this is the ray diagram. Okay, so now we will see the cases, okay, where the object is placed. So in your classes you have learnt about different positions of the object. So now here I am taking the object at infinity. So let this be at infinity point. Okay, so when the object is placed at infinity, the R1, R2, for your convenience I am taking out R3. Okay, so now see, for when the object is placed at infinity, so what? The rays are traveling parallel to the principal axis and passing through the focus, and the ray is traveling through the focus and parallel to the principal axis. Is it clear? So these 2 rays, they are meeting at this point and the image is formed at this point. Okay, so now when the object is placed at infinity, where you got the image? The position is between C and F, that is the image is formed between C and F. And what are the characteristics of the image? Inverted, diminished. Is it clear? So what are the characteristics you can say of this image? The characteristics are inverted, diminished, as well as it is a real image. Clear everyone? Now we will go for another situation when the object is placed beyond C. Okay, so this 2F is nothing but the center of curvature. So now I am placing the object where? Beyond C. So when the object is placed beyond C, see the rays are traveling and they are meeting at this point. Okay, so the image is formed at this point. So when the object is placed beyond C, where is the image formed? It is formed between focus and center of curvature. That means it is formed between C and F. Okay, and what are the characteristics of the image? Inverted image and diminished image, as well as it is a real image. Okay, so now we will try a R3 diagram for this. See, this is the R3 ray. Okay, now we will place the object on C, that is on C. So when you place the object on C, what happens? When you place the object on C, the rays are traveling and they are meeting at this point. So you can see that a large candle, right? But it is not a large candle, but it is the image. That means when you place the object at C, the image will also form at C. Okay, and you can also see the values here down. Object distance and image distance. That means when we are placing the object at 40, the image distance is also 40. Is it clear? And what are the characteristics? The image is real image and it is an inverted image, and also the size of the image is same. Is it clear? See, here it is 2 boxes and here also it is 2 boxes. Is it clear? So on C, what are the characteristics of the image? The image will be formed on C itself, and the characteristics are inverted image, same size image and real image. Okay, now we will make the object placing between F and C. Okay, so now the object is placed between F and C. Now we will see where the image will be formed. So this is the R1 ray, right? And this is the R2 ray. Is it clear? Clear everyone? See, now the image is formed here. So you might be getting confused that here the rays have not met. So you can decrease the size of the image. See. You can decrease the size of the object. That means if you take a bigger object, image will, that means the size of the object will depend on it. Is it clear? See now. So if it is placed between F and C, okay, the image is what? Formed here. So where it is formed? It is formed beyond C. And also what are the characteristics of the image? Enlarged. See, the size of the object is only 1 box. But here you can see the image has image sizes more than 2 boxes. Is it clear? So that's why the size of the image is enlarged, as well as it is a inverted image, as well as it is a real image. Now we will see when an object is placed on F, that is when the object is when the object is placed on F. So when the object is placed at F, so the rays, this is the R1 and this is the R2. Okay, so when you place the object on F, the image will be formed at infinity. So here it is showing this as a image. Why? Because we cannot see the image where it has been formed. That's why it is showing the symbol like this. That means the image is formed beyond infinity. That means beyond C, but we cannot see. Okay, that means what are the characteristics of the image when the object is placed at F? we cannot see the image. So it is at infinity the image will be formed and we cannot say the properties. Okay. Now I am placing the object between F and pole, that is between F and P. Okay. So now when I am placing the object between F and P, see the rays R1, R2. Okay. So these are the two rays, and in this case I have already said in the class that what we need to extend the backward rays to meet it. Okay now. So here by extending the reflected rays backward, you can see a point meeting over there. That is nothing but called as a image point. Okay. Now the image formed here is not a real image. Why? Because the image is formed by extending the rays backward. So this is a virtual image. Okay. And what are the characteristics of the image? It is formed. That means when an object is placed between F and pole, the object is formed behind the mirror and it is a virtual image and size of the object is enlarged. So these are the cases when the object is placed in different places in concave mirror. So concave mirror is also called as a converging mirror. So randomly I will select the place of the object and show you where the object is formed. Okay. See now. You can observe the difference when the object is changing its position. Can you see it? I think you can see it. What is the difference? Okay. Clear everyone? So, this is the ray diagrams in concave mirror. Sorry, it is concave mirror. Now, we will see in a convex mirror. See, now this is the object, right? This is the object and focus will be same as this. Here it has two boxes and here also it will be two boxes. Okay, and here it has two boxes center, here also it is two boxes center. Now we will see when the object is placed at infinity. Okay, for convex mirror. So assume this as a convex mirror because we have placed the object this side. Okay, so now it is acting as a convex mirror. Okay, so I am placing because it is at infinity, see like this. Okay, so here it is at infinity. So when you place the object at infinity before a convex mirror, we will see the ray diagrams. So this is the R1 ray. Okay, so already in your class you have learned that a convex mirror is a diverging mirror. So we need to extend the rays backward in order to get the image, right? So here also see the R1 ray is traveling parallel to the principal axis and when it is meeting the convex surface, it is getting reflected. Okay, so already we know R1 ray is what? It is traveling parallel to the principal axis. The reflected ray should travel, that is it should pass through focus. So now here what we will do, we will try to assume to extend the ray backwards. So when you extend the reflected ray backwards, it will pass through focus. Clear? So this is R1 and next is R2. Can you see this ray? So what is the R2? R2 ray is the ray which is passing through focus. So you might have get doubt. Teacher, here there is no focus. But how to draw the line which is passing through focus? Is it clear? So we will draw a line passing through focus, assuming it. Okay. See now. This is the ray which is passing through focus. So when you extend it, it is meeting the focus, right? And when it is passing through focus, the reflected ray travels parallel to the principal axis. So in order to get the image, I need to draw the reflected ray backwards. Okay, so these two are meeting at this point. So this is the place where the image is formed. So when you place the object at infinity, what happens? The image is formed between F and P. And what is the characteristics of the image? it is small, that is it is erect image and it is a diminished image. Okay, sorry, in the case of concave mirror, when the object was kept between pole and focus, the image was a virtual image and it was also erect image. Why? Because why it is a erect image? Because the object was formed in the same way as the object. Okay, the image was formed same as the object. Okay, that means how was the candle placed? Same like that you have got the image. But in the before situations, you got the inverted candle, right? Now we will go for convex. Clear everyone about the infinity when the object is placed at infinity? So now I am moving. See, now I am taking out the rays and I am moving the object. Can you see the difference? See, here it is F. So here to F and F. So that means it is beyond C, right? So when the object is placed beyond C, you can see the image. Okay. So R1 ray, same explanation as of before. Okay. Next is R2 ray. Okay. You can also see R3. Okay. So these three rays are meeting over here. So in this case also, the image is forming between F and P, but somewhat farther to focus. Okay, and the size of the image is diminished and it is a virtual image and it is a erect image. Now we will see when the object is placed at C. That means I am comparing you the places, but whenever you place an object before a convex mirror, always it forms a diminished image and erect images. Is it clear? So now if it is placed at C. Okay. So now see R1, R2 and R3. Is it clear? So here the image is formed. So are the characteristics same as before? Yes. Okay. Now I will move the object between C and F. Okay. So don't take that where C is, where is F is. I am comparing with these same side because see, 2 blocks you have F. So 2 blocks F and you have 2 blocks 2F. So 2 blocks 2F. Like that I am comparing and saying you. But in a convex mirror, wherever you take, the image will be formed between F and P. Is it clear? And always the image will be same size. Always the image will be erect and it will be between F and P and it will be a diminished image. Okay. So now I am placed here. I am giving you R1, R2 and R3. See, this is how the image is formed. Is it clear? Now I will change. See, here also the image is formed between F and P and the size of the image is diminished and you got a erect image and it is also a virtual image. Why? Because here also we are extending the rays and drawing it. Okay. Now we will see when the object is placed at F. Okay. So see now, when you place the object at F, you can see that the image has moved exactly into the middle of F and P. Okay. Now we will draw the ray diagrams for R1, R2 and R3. Okay. Is it clear? What are the characteristics? Same. Virtual image, erect and diminished in size. Okay. Now we will see when the object is placed between F and P. Clear everyone? Can you see a difference? Okay, these are the rays. So here also diminished size, erect image and virtual image. So in all these cases you have seen that the image is formed between F and P only. It is changing the places, but it is formed between F and P only, and always the size of the image is diminished and always it forms a erect image in convex mirrors. Okay, and that's why these convex mirrors are called as diverging mirrors. Hope you like the session. Thank you.